In this video, I'm going to go through the solutions to Unit 2 test one by one. The first question, which is a multiple choice, it's asking to find the restrictions of this rational function. Remember, the restrictions are the values that make the denominator equal to 0. The denominator in this case is x times 3x plus 2. If we make it equal to 0, we get either x equal to 0 or 3x plus 2 is equal to 0. I move this to right, I get 3x is negative 2, so x is negative 2 over 3. Now, looking at the options, you can see that the correct options is option C. The next question is to find the lowest common denominator for the given rational function. To find the lowest common denominator, you can see that x plus 1 and x plus 3, so it's x plus 1, x plus 3, and this one has x minus 2, so times x minus 2, and for this one x plus 3, x minus 2 is already included, so the lowest common denominator is x plus 1, x minus 2, and x plus 3, which is going to be option E. The next question is to consider the graph of f of x is negative 1 over 2 times 2x plus 4 squared minus 4. I can write this equation as negative 1 over 2 open bracket 2 times x plus 2 squared minus 4. Now going through the options, the first one says option A, vertically expanded by a factor of 2. And you can see that your A value is 1 over 2, so it's not vertically expanded. So this option is gone. Option B says vertically compressed by a factor of 1 over 2, which is correct because your A value is 1 over 2, so this is correct. Option C says that it's horizontally compressed by a factor of 1 over 2, which is correct because your B value is 2, so its compression factor is 1 over 2, so this is correct. And option D says horizontally expanded, which is incorrect because your B value is greater than 1, so this is incorrect. Option E says both B and C, and you can see that B was correct and C was correct, so this is correct. And option F says both A and D are correct, which is not. So this is not correct. So the answer is option E. The next question says that if negative 3 and 1 is in the function f of x, then which of the following points will be in the function f minus 1? Remember, function f minus 1 is going to swap the x and y values. So this means that 1 and negative 3 is going to be on f minus 1. And 1 and negative 3 is option A. The next question says which one of the following statements is not true? The first option, the inverse of a quadratic relation is a function. Remember, a quadratic relation when plotted is going to give us a parabola like this one. The inverse of this one is going to be something like this one. And it doesn't pass the vertical line test, so this is correct. The next one says the inverse of a linear relation is another linear relation, which is correct. Okay, so this is not the one. The inverse of a relation is found by interchanging the domain and range. This is true, but this question wants not true, so this is not the answer. The domain of an inverse is equal to the range of the original function. Again, this is true, but this question wants the one which are false, so this is not. So the answer is A in this case. The next question asks, if f of x is 5x minus 7, what is f of minus 1? So I'm going to write f is equal to 5x minus 7. I'm going to bring negative 7 to the left. I get f plus 7 is equal to 5x. Divide by 5. I'm going to get x is f plus 7 over 5, or f minus 1, the last step. Replace x with f minus 1 and f with x. And if you look at these options, the only one which is true is going to be option D. The next question is to simplify this rational expression and state all the restrictions on the variables. I can write 9x squared minus 1 as 3x minus 1 times 3x plus 1 over x cubed plus 2x squared minus 15x. I can factor out x, and I'm going to get x squared plus 2x minus 15 divided by 9x squared plus 6x plus 1. I can write it as 3x plus 1 squared over, and the bottom one, the leading coefficient is 1, so I use sum and product to find two numbers with a product negative 50 add up to negative 5. The answer is negative 10 and plus 5. Now I'm going to also factor out the denominator of the first fraction. I'm going to write this one as 3x minus 1 times 3x plus 1 divided by x. The leading coefficient is 1. Find two numbers, product negative 15, add up to 2, and those are 5 and negative 3. So it's going to be x plus 5, x minus 3 divided by 3x plus 1 squared over x minus 10, x plus 5. To start simplifying, I have to write the restrictions. The restrictions are everything that makes the denominator 0. So x can't be 0, x can't be negative 5, x can't be 3, x can't be 10, and again x can't be negative 5, which is already included. Now safely I can go ahead and simplify the numerator and the denominator. Now to start simplifying, as you can see, there is nothing in the denominator and the numerator which I can factor out or cross out. But this division, I can flip the second fraction and then I multiply. So I get 3x minus 1, 3x plus 1 over x times x plus 5, x minus 3 times x minus 10, x plus 5 divided by 3x plus 1 squared. But before I continue, remember that the restrictions are going to be copied here. Again, the same restrictions, 0, negative 5, 3, and 10. But now I have introduced another restriction, which is this one. So x can't be negative 1 over 3. Now I can go ahead and simplify these. I have a 3x plus 1 and 3x plus 1 squared, so this square is going to be cancelled. I have x plus 5 and x plus 5 are going to be cancelled. So I'm going to end up with 3x minus 1 here from this one and x minus 10 here divided by, I'm going to get an x here times x minus 3 times 3x plus 1. And the restriction stays the same, which is 0, negative 5, 3, 10, and negative 1 over 3. This is our final answer. The next question is about simplifying x plus 10 over x minus 1 plus x minus 3 over x plus 2. I'm going to get the common denominator. The common denominator is going to be x minus 1 times x plus 2. So the first fraction, I'm going to multiply numerator and the denominator by x plus 2. And the second denominator, I'm going to multiply the numerator and denominator by x minus 1. So x minus 3, x minus 1. Now, if you look at the fractions, you will see that they have the same denominator. So the denominator is going to be x plus 2, x minus 1. And then I'm going to expand the numerator. I get x squared plus 2x plus 10x plus 20 from here, expanding this, plus x squared minus x minus 3x plus 3 from expanding this one. Before I continue, I'm going to write the restrictions. The restrictions are x cannot be equal to negative 2 and x cannot be equal to 1. Now, if you simplify the numerator, you are going to get 2x squared plus 8x plus 23 divided by x plus 2 times x minus 1, and x cannot be negative 2 or 1. The next question is about completing a chart. Our function is y equal to square root of 2x minus 4 minus 4 again. I can rewrite this one as 2 square root of 2 times x minus 2 and then a minus 4 outside the square root. Now looking at this one, you can see that our a is 2, our b is 2. So let me write it. A is 2, b is 2, h is 2, and k is negative 4. So the first question is that is it stretch or compression vertically? You can see that a is 2, so it's vertical stretch by a factor of 2. So I'm going to write it vertical stretch by a factor of 2. Then it asks about horizontal. Since b is equal to 2 and it's greater than 1, so it's going to be horizontal compression, and the factor is 1 over b, which is 1 over 2. Then it says vertical translation. You can see that k is negative 4, so it's going to go down by 4 units. And then horizontal translation, either left or right, you can see that h is 2, so it's going right by 2 units because h is 2. And then reflection, since a and b, there is no negative sign in front of them, so there is no reflection. The next question is about graphing a rational function. The function is g of x is 2 over x minus 2 plus 1. The first part is what is the base function. The base function is obvious, is going to be f of x, or f is equal to 1 over x. Write the mapping notation. If you look at the transform function here, you can see that a is 2, b is the coefficient of x here, which is 1, h is 2, and k is 1. So the mapping notation is going to be xy goes to 1 over b, so 1 over 1, which is 1, x, plus h is 2, and y becomes ay, which is 2y, plus k, plus 1. So this is going to be our mapping notation. Now draw on the graph vertical asymptote, horizontal asymptote. Our vertical asymptote, remember, is anything that makes the denominator equal to 0. You can see that the denominator here is x minus 2. So if that one is 0, x is equal to 2. So x equal to 2 is going to be our vertical asymptote. For horizontal asymptote, we can find the simplified fraction, which is going to be g is going to be, if I take the common denominator of x minus 2, so I'm going to multiply y by x minus 2 and divide by x minus 2. I get x minus 2, and then 2 plus 1 times x is x, 1 times negative 2 is negative 2. This gives me x over x minus 2. Now, to find the horizontal asymptote, I will let x go to infinity. Then you will see the term which contributes the most in the numerator is x, and the one in the denominator is also x. X over x is going to give me 1. So this means that the horizontal asymptote is 1, which is going to be this line here. Now we are supposed to fill the table of values given and then plot the points. For the base function f of x here, we are going to sub x negative 4. So if I put x negative 4 in this equation, this is the base function, I get negative 0.25. If I put negative 3, I get negative 0.3. If I get negative 1, I get negative 1. If I put 1, 1 over 1 is 1. Then 2 is 1 over 2 is 0.5. And then 3 is 1 over 3 is 0.3 approximately. Now I'm going to use this mapping notation that I have here, apply it to x and also to y to get x and y of the transform function. So let's start with x. If x is negative 4, I put it in this. Negative 4 plus 2 gives me negative 2. If x is negative 3 plus 2 gives me negative 1. If x is negative 1 plus 2 gives me 1. If x is 1 plus 2 gives me 3. If x is 2 plus 2 gives me 4. If x is 3 plus 2 gives me 5. So these are the x values of the transform function. Now we are going to do exactly the same thing, but this time on the y values. So if y is negative 0.25, 2 times negative 0.25 is negative 0.5, plus 1 is going to give me 0.5. If y is negative 0.3 times 2 is negative 0.6 plus 1 is 0.4. If y is negative 1, 2 times negative 1 is negative 2 plus 1 is negative 1. If y is 1, 2 times 1 is 2 plus 1 is 3. If y is 0.5, 2 times 0.5 is 1, 1 plus 1 is 2. If y is 0.3, 2 times 0.3 is 0.6 plus 1 is 1.6. Now I'm going to use this table of values and plot the transform function. When x is negative 2, which is here, y is 0.5. So the point that I'm going to get is this point somewhere around here. When x is negative 1, y is 0.4. So I get a point close to the x-axis here. When y is 1, when x is 1, y is negative 1. When x is 1, y is negative 1, which is here. When x is 3, y is 3, which is going to be here. When x is 4, y is 2, which is going to be here. When x is 5, 1.6 is the y value, which is here. Now, if I roughly connect these points together, I get a graph like this one. And over here, I'm going to get a graph like this, which is not going to cross the horizontal asymptote. So this is going to be my transformed function. The last part of the question asks to find the domain. If we look at the graph here that we plotted, you can see that x can be any value except the vertical asymptote, which is here, which is x equal to 2, and also y can be any value except the horizontal asymptote, which is y equal to 1. So I can write that domain is x in R, and x cannot be equal to 2, and the range is y in R, and y cannot be equal to 1. The next question, we have a function f of x is equal to 2 times x minus 1 squared minus 3. We are supposed to find the minus f of x, part I. So this means that I multiply f of x by negative 1, so I get minus f of x is equal to negative 2 times x minus 1 squared. Negative times negative 3 gives me plus 3. So that's my first one. The second one says f of minus x. This means that substitute minus x instead of x in the equation. So I'm going to say f of minus x is 2 times, instead of x, put minus x, minus 1 squared minus 3, which is going to be 2 times negative x minus 1 squared minus 3, or you can go one step further, you can factor out negative, so you get 2 times negative x plus 1 squared minus 3, but negative to the power of 2 gives you positive, so you get 2 times x plus 1 squared minus 3. So if you leave it like this, you're okay. If you leave it like this, you're still okay. The next equation is to find the inverse of f of x. We know that f of x was given by 2 times x minus 1 squared minus 3. So I have to isolate x. I'm going to bring negative 3 to the left. I get 2 times x minus 1 squared is equal to f plus 3. So x minus 1 squared is f plus 3 over 2. Take the square root, I get x minus 1 is plus or minus square root of f plus 3 over 2. Now move negative 1 to the right, I get x is 1 plus or minus square root of f plus 3 over 2. And the last step to replace x with f minus 1 and f with x. The next part of the question says the range of minus f of x. This is minus f of x. You can see that this is a parabola. The vertex for this parabola is at 1 and 3. And it opens downward because of negative 1 here, so we can say the range is y in R, and y has to be less than or equal to 3 because the maximum value of the vertex is 3. The next part, it says find the range of f of minus x. F of minus x is this one that we found before. And since a is positive 2, so the parabola opens upward, and you can see that the vertex is negative 1 and negative 3. So we can say the range of f of minus 1 is y in R, and y has to be greater than or equal to negative 3. The next part of the question is find the range and the domain of f minus 1x. If you look at the f minus 1x, which is found here, you can see that the range is, as long as this value is going to give you a positive value, f minus 1 is defined. So we can say that the domain is x in R, and x has to be greater than or equal to -3. But the range for this one, if you try to plot this one, you are going to get a parabola which is sideways. And this one means that your range can be any number from -infinity to +infinity. So range is going to be y in R. The next question is to find the equation of a transform function if the following transformation is performed on the base function f of x is square root of x. So the transform function is g of x. The first thing is it goes under a vertical stretch of a factor of 2, so we're going to get a 2 square root of x. Then it has a horizontal compression by a factor of 1/3, so it means that we have a 3 here, 3x, a reflection in the x-axis, so this means there is a minus here, a reflection in the y-axis, so there is a negative here, and then a reflection in the y-axis, a translation of 6 units to the left, so this means that your x is going to be +6 here because it goes to the left, and a translation of 4 units upward, so it's going to be +4. So this is going to be our equation, -2 square root of -3 times x plus 6 plus 4. The next problem is that f of x is given the graph on the right here. We are supposed to graph the inverse. So the way we do it, we use the property of the inverse function, which is the same as f of x, but the coordinates of x and y are interchanged. So whatever the coordinate is in f of x, we just change x and y, we flip them. So we are going to start with this point. This point, the coordinate is, as you can see from the graph, is going to be 1 and 3. So on the inverse, it's going to be 3 and 1. Instead of 1, 3, it's going to be 3 and 1. So 3 and 1 is going to be this point. This is going to be the first one. So if I call this one A, this becomes A prime. Let's go and find this point. At this point, the coordinate is 2, 2. So if you flip it, you're going to end up with the same coordinate. So if this is B, B prime is going to be on the same point here. Now, remember that in the original function, A was connected to B through a curve. So A prime to B prime is going to be also through a curve. So let's draw something like this one. Now let's go and find this point. This point has the coordinate of 3 and 3. Let's call it C. The inverse, C prime, is going to have the same coordinate, 3 and 3. So C prime is here. Now, in the original function, B was connected to C, so B prime is going to be connected to C prime, something like this one. Now, let's go find the next one. The next one, let's say this point, D. D here has the coordinate 5 and 0. The inverse is going to have 0 and 5, which is going to be the point here, D prime. D prime. Now, if you look at the main function, the original function, C was connected to D, so now C prime is connected to D prime, which is going to be a line like this one. So our graph is D prime, C prime, B prime, A prime. This is the new inverse. Now the question is that, is the inverse a function? You can see that the inverse is not a function, because if I draw a vertical line like this one, there is 1 intersection, 2 intersection, and 3 intersection. So the inverse is not a function. The next question is about the equation which changes Fahrenheit to Celsius. We are supposed to rearrange the equation to find the Celsius in terms of Fahrenheit. So what I'm going to do is that I'm going to move 32 to the left, so I'm going to get 9 over 5 C is F minus 32. Now I'm going to multiply both sides by 5 to get rid of this 5 here, so I get 9C is 5 times F minus 32. Now I'm going to divide by 9. I'm going to get C is 5 F minus 32 over 9. Now the question is that you're supposed to explain how the above two equations are an example of a function and its inverse. Simply, we can say that the first equation, you can get f if c is given, which is going to give you a point CF. If c is given, I can find f. In the next one, I can find c if f is given. So I can find c if f is given. And you can see from these 2 points that c and f and c are swapped. And this is an example of inverse functions. In the next example, we have to find the length of a rectangular field if the area is given by x squared minus 7x plus 10 divided by x squared minus 4, and the width is given by x squared minus 4x minus 5 divided by 3x plus 6. We know that in a rectangle the area is length times width, so this is going to be multiplied by length. Now I have to solve this one for length. To do that one, I'm going to write the fractions as factors. The numerator here, the leading coefficient is 1, so find 2 numbers, they multiply to 10 and add up to -7. Those are -2 and -5, so I can write x minus 2, x minus 5 divided by x squared minus 4 can easily be written as x minus 2 times x plus 2. Now here again, leading coefficient is 1, find 2 numbers, the product is -5, add up to -4, or 1 and -5, and the denominator I factor 3 out, so I get x plus 2 times L. I'm going to write the restrictions, so the restrictions are 2, -2, and that's it. And this one is going to be -2, which is already included. Now I'm going to cross multiply here. I'm going to say x minus 2 times x plus 2 times x plus 1 times x minus 5 times L. This numerator times this denominator is equal to this times this, which is 3 times x plus 2 times x minus 2 times x minus 5. Now I can say that L is 3 times x plus 2, x minus 2, x minus 5 divided by x minus 2, x plus 2, x plus 1, x minus 5. Now our restrictions so far were 2 and -2, but now we have -1 and also 5 here. Now I can simplify x minus 5 with x minus 1, x plus 2 with x plus 2, x minus 2 with x minus 2, so I'm going to get 3 divided by x plus 1, and the restrictions are going to stay the same, which is 2, -2, -1, and 5. And the last question was the function f of x is x squared plus 4. Explain why f of x is equal to x minus 4. I'm going to replace x with minus x, so I'm going to get negative x squared plus 4, which is going to give me x squared plus 4, which is going to be the same function. So this is one way of explaining it. Another way of explaining it is that when you change x to minus x, this means that the function is reflected about the y-axis. If you look at f of x can be written as x minus 0 squared plus 4. This means the vertex is at 0 and 4. So 1, 2, 3, 4. This is my vertex here, but since the coefficient here is 1, positive 1 is going to open upward. Now, if you reflect this one about the y-axis, you can see that every point is going to go back on the same parabola. So that's why the function stays the same when you reflect it about the y-axis.